You ready?
Good evening. No, that's my job. Sorry.
Oh, that's your job?
Yep.
Turn this on?
Hello, ladies and gentlemen. Welcome back to Disney Channel. Welcome back, campers. Today we have the motor and the coupling. This is what I'll be explaining today. The motor itself appears to be a DC motor, specifically rated for 230 to 460 volts. There's a max ambient temperature of 40 degrees Celsius with a serial number of 2021-05. It's connected to this coupling, which reduces shock and also vibration when transferred from rod to rod down there. So now we're gonna do a little science experiment right here. Turn that on, turn on the circuit breaker, put this in forward, turn on the speed, and voila.
So these are the wheels and this is the belt. The whole purpose of it is to transfer energy. The wheels are also different sizes by about an inch, and this wheel increases the speed of the smaller wheel because of the rotation.
So, what holds up the shaft and wheels in place are these mounts, which allow the movement through use of ball bearings within these, what would you call that, brackets? And that's probably not the correct technical term.
No, just brackets. Within the mounts.
Correct. So maybe now we should turn it off.
Now that we have the belt and the whole motor and system off, we already checked for alignment way before this, but how we did it, we placed this against like so, looked down the middle, and made sure that end was to end without it going off course. The best way was having this side and this side, so that when you go down, it will also be even with this. So this end of the wheel and this end of the wheel have to be square with the divide, or the bar, I should say. And then this, at least one side also be square with this side of the bar. Then the next thing we used was belt tensioning to make sure that it has the correct amount of poundage per square inch that's kind of like used. And yeah, it's just simple down, and when it stops, and you read the amount of poundage that it has, or basically how tight the belt is.
Alright, so last, what we did was we calculated out the drive ratio, or the ratio of power transferred, I guess, by taking the radius of the larger main drive and the radius of the smaller or driven drive and comparing the two. So on the main drive, it was 2 3/4 inches radius, and on the driven or smaller gear, it was 2 1/4 radius. So that was a total gear ratio of 1 2/9, or 1.2 repeating onward. Then the speed since changed, so we might get different readings. However, when we read the rotations per minute off of the main drive using a tachyometer, checking on a piece of reflective tape, we got a rating of about 970.4 rotations per minute, RPM. Calculating out using that drive ratio, we got a result of 1,186 RPM, and measuring it off of that, we got fairly close to about 1,160 RPM.
1,196.
Okay, so yeah, we were able to closely calculate out what that result was just through the use of, one gear's RPM and then transferring it via the gear ratio. And what that tells us is that the transfer of power, we are gaining speed, but losing torque, just by virtue of the golden rule. All right. Thank you.